All right, so now we're going to go show sketches of all these different things. And this is where our chihuahuas and bears are going to come into play big time. So show sketches of A, we'll do first. I'm going to zoom in big time on A for the at-home audience. Okay, A is of molten sodium chloride. So looking at this, if we have molten sodium chloride, can anyone tell me what it means to be molten?
Melted.
Melted. Why do we need to melt the sodium chloride before we put it in a cell?
So electricity.
It's easier to solve.
Let's say that loud. It was perfect.
So electricity can go through it?
So electricity can go through it. Perfect. That would be Robert Hunt. I'll give you credit. When it's right, when it's wrong, I'll just say it's Brooks. No, I'm kidding. Na plus Cl minus. So by heating it up as high as it is, it's breaking the lattice, it's making the ions free for electricity, for movement of electrons. Electrons have to be able to move through this. Now we're still going to be, I'm just going to leave it positive and negative. Positive being the anode, this being the cathode. What happens at the anode again? Oxidation. And what happens at the cathode? Reduction. Now, our electrons, or our chihuahuas, are running through, and we're going to reduce and oxidize things here. The reduction and oxidation of this stuff here is going to happen, in this case, each one of these is going to be reduced and oxidized. One of each is going to be reduced and oxidized because there's nothing else there. Okay? The chihuahuas are hungry. Which one of these, looking at the numbers, do you think can be reduced? Only one can be reduced. Only one can go down in charge.
Cl.
Well, actually more than one, but no, Cl, what would that go down to?
Oh.
Wouldn't sodium? Okay, so here's the thing that's going to help you. All metals get reduced. Non-metals get oxidized. Non-metals are polyatomics. So what is this going to be reduced to? Na plus is going to go to Na, right? And then where do I put my electron? On the left. What is this going to be oxidized to? What is chlorine going to be oxidized to?
Cl2.
Cl2, so go ahead and put that down. So chlorine is going to go from Cl minus to Cl2, but to balance that half reaction I need 2 plus 2 electrons. Okay, so what's happening then at the cathode, metal's being reduced, and we are producing sodium. It's actually plating this electrode with sodium solid, and here we're producing chlorine, nice chlorine gas, pleasant smelling, deadly chlorine gas. So how this applies to the AP, and remember, I don't know if y'all remember, when we did AP equations, I said skip all the problems that said electrolyzed in them. Do y'all remember me saying that?
Yes.
That's what's happening here. If you get a problem now that says molten sodium chloride is electrolyzed, you now can write an AP equation for it. What would that be? Sodium chloride, molten, is electrolyzed. You'd write that, and what would you write as your products?
Cl2.
Cl2 and
Na.
Na. And then you'd put a 2 there, and a 2 there, and then you need a 2 there, and that would be your answer to that AP equation. That seems easy because water's not in play. We're about to throw water in, and then things are going to change. But right now, these chihuahuas, these electrons, all they have to attack are those things. They got to eat, they got to attack. That's what's going to happen. Okay? So now let's go ahead and make things a little more crazy and look at B, and we're going to electrolyze aqueous sodium chloride. Aqueous sodium chloride. So that means there's water in the mix. So we have in the vat Na plus, Cl minus, and this time water as well. Okay. So again, plus, minus, and this is the last one we're really going to draw because we don't need to draw these anymore after this. And then I've got water in here, I've got Na plus in here, and Cl minus. So see the phrasing? Molten versus aqueous, right? Now, Plus is the anode where oxidation occurs. Minus is the cathode where reduction occurs. What two things could be oxidized here?
H2O and
Water or
Cl minus.
Cl minus, correct. What two things could be reduced?
Water and Na plus.
Water and Na plus. Well, here's where we're introducing the new concept of bears. Chihuahuas are afraid of bears. Bears attack chihuahuas. Chihuahuas will not attack the bears for food unless they absolutely positively have to. What are bears? Bears are group 1 and 2 metal ions and polyatomics. And I will show the at-home audience these pictures momentarily, but the rest of you here, there's your bear. That's your group 1 and 2 metal ions. There's polyatomic. I wouldn't want to mess with her. And there's little water. Water likes to be reduced and oxidized, like, hey, how's it going? And then here's the chihuahua. All right, so
Intimidating.
chihuahua's bigger than, almost as big as the bear. It's a big chihuahua. Anyway, so with that being said, now that we have some choices here, of the two being oxidized, are either one of those bears?
No.
No, right? Chlorine minus is not a bear, water's a bear. Water's boring. They don't want the chihuahuas don't want to drink water if they don't have to. They're not, there's no bear there to attack, so to attack them. So they're going to go ahead and go for the cool chlorine. And they're going to oxidize the chlorine and make what?
Cl2.
Cl2. Okay? And that means that I need 2 electrons. Now look at the two things being reduced. Do I have a bear? Yeah, what's the bear? Sodium. Uh-oh, that's a bear. So that's not going to be reduced. What's going to be reduced instead?
Aqua.
Water. And what's the products of the reduction of water?
H.
H plus, and it's basic. Don't worry about balancing that. We don't need it balanced right now. So, with that being said, if that's basic, and that's now H2 is being produced, we know that in this picture, we're making chlorine gas at the anode and hydrogen gas at the cathode with some OHs hovering around the cathode. So, an AP equation would be very different. An AP equation would say what happens when aqueous sodium chloride is electrolyzed. If that's the case, you would have to write what is your reactants?
2Cl minus and H2O.
We write H2O, Cl. You can put Na in there while you're trying to think it out in the process of the problem. You can say, okay, I've got water, I've got chlorine, I've got sodium. So, water can be reduced and sodium, but sodium's a bear. So instead, we're going to make H2 plus OH minus. And then if chlorine is oxidized, that makes Cl2. And then you go and balance it. So do you see why that would be really hard to understand unless you had electrolysis? You would be like, what the heck? Where did that come from? All right, and we're going to practice some more of these AP equations. Now all your extra credit AP equations are going to have electrolytic cell stuff on it, or electrolysis questions. Yeah, I know. Okay, let's see if we can do C without drawing. Aqueous iron 3 sulfate. So what's present? Aqueous and Fe plus 3 and
SO4 minus 2.
SO4 minus 2. Okay, the cathode is reduction, so what two things can be reduced?
SO4 minus 2.
H2O.
H2O and metals are reduced. Okay, so which one's going to be reduced?
H2O.
Ooh, is this a bear?
No, it's not.
No, it's not a bear, so we're going to take that to iron. Okay, then we got the anode and oxidation. Okay, what two things can be oxidized?
H2O.
H2O and
SO4 minus 2.
sulfate. Bears are bear. Sulfate's a polyatomic. So then what are we going to make?
O2
H2.
O2 and H
plus.
plus. Okay, so those are our products. At the cathode, we're going to make iron, and at the anode, we're going to make oxygen and H+. Now, if on the AP they ask you why is this oxidized and that's not, you cannot say because it's a bear. Yeah, that won't work. What I want you to say is just, all you have to say is water is more apt to be oxidized than sulfate. That's all you need to say. Because what you really have to do in these problems, you have to write, the real way is to write a half reaction for both of these. Go to the reduction potential table, see which one has the higher reduction potential, or if it's oxidation, you have to flip them both and see which one is more apt to be oxidized. It gets really confusing and it's really slow. This cuts down your time a lot. All right, D is the last one. Aqueous sodium sulfate. What do we write? Water, Na+ and sulfate. All right. What two things can be reduced?
Na+ and H2O.
Na+ and H2O. What two things can be oxidized?
H2O.
SO4 minus and H2O. So what's going on here?
H2O and H2O.
H2O is both oxidized and reduced, so we're back to that original equation of making H+ and OH- here, and O2, not H+, sorry, H2 and OH- and O2 and H+. Okay, so we only reduced and oxidized water. Does that make sense? Job, any questions?